Hello. Question 7 asks us to find the closed form solution of a linear regression model given this data up here. Now what we're going to do is I'm going to go over the closed form solution formula, which is right here. You can find this in the lecture. This will probably not be provided on the test, so it is very good for you to know this formula. Now you're going to notice that this is big X transpose, and we don't have big X. We need to make capital X, which is our feature map in this case. And we can see our function here. So we have an x squared term and a normal x term. So remember, phi of x is our feature map. And remember that this is always our x terms. So x, well, phi equals x, which is going to equal our feature map. This is going to be x1 squared, x2 squared, x3, not cubed, squared, x1, x2, x3. We're going to have w equals w1, w2, and we're going to have y equals y1, y2, y3. Okay, that should be good. Now let me just pull it down here. Okay, now let's fill this out. So x1 squared for -1, 0, 1. So x1 squared is going to be 1, -1, 0, 0, 1. This is what this is going to be. That's what our feature map is going to be. So if we multiply this out, we're going to have x transpose x. I'm going to take the inverse of that times x transpose times y. Now x transpose x, it's going to be 1, 0, 1, -1, 0, 1, 1, 0, 1, 1, 0, 1, and we're going to get 2, 0, 2, 0. Okay, now we need to find the inverse of this. One way of finding the inverse of these matrices is to augment them with the identity matrix and do row reduce. So in this case, all we do is we divide it by 1, by 2 on each side. So we get 1, 0, 0, 1, 1 half, 0, 0, 1 half. And I know that this is the resulting inverse of this matrix as soon as I can get a diagonal of 1s here, or the identity matrix. Okay, so that was x transpose x inverse. So now we have 1 half, 1, 0, 0, 1. This is dotted with x transpose, not little x, big X. And then that is dotted with y. So what I can do is multiply this by x transpose. This is going to be 1, 0, 1, 1, 0, 1. So that will get us, let's see, 1, 0, 0, 1, 1, -1. So you might see that this is, I feel kind of foolish, but this is the identity matrix, so we're going to get x transpose out of this. So it's just 1 half x transpose y times y, and y what are y's terms? 3, 0, 1. 3, 0, 1, and that gives us 4, -2, and that is multiplied by 1/2, so our answer is 2, -1. Those are proper weights, so W1 equals 2, W2 equals -1, and these are the optimal weights for the given data.